Hey everybody, so it turns out that I'm so good at jury duty that I need to go back tomorrow. Ugh. Oh well, gotta do your civic duty. But anyhow, I just really want to make sure that you guys are okay with this quiz review worksheet, so let's go through that today. I really hope that I'm back with you tomorrow. That'll just be a minimum day where we review a little bit more, and then we're going to end up going and taking care of that quiz on Thursday, and man, I hope I'm there with you. So without further ado, let's take care of this quiz review worksheet. So ready, go! All right, let me just go ahead and swivel this camera around, little rotation there. That's a little transformation reference. All right, so quiz review worksheet. Let's take a look at this first one. Keyword there is classify. You guys know that that means simply, hey, give it a name. And this time it looks like we're going to make sure that we do it by angles. Your options when it comes to classifying by angles, let's think about this. You have the ever so fun to pronounce equiangular. That's if all three angles are the same size. You have an acute triangle. That's if all three may be different, but yet they're all less than 90. You have an obtuse triangle, which means if you have one angle that is greater than 90. And finally, you have a right triangle, which means that one angle and exactly one angle is 90 degrees. So let's take a look at these. Triangle ABD, remember that means you go in order from A to B and then to D. I'm noticing that that has a 100-degree angle in it, so I'm going to go ahead and instantly classify that as obtuse. Triangle BDC, from B to D to C. So there's some missing ones, and I think it would be a smart move to try to get those filled in. This angle right here, if this one's 100 and together these two are a linear pair, meaning they make 180 degrees, that means that this one would be the straight line of 180 minus the 100 that was next to it, which means it has to be 80 degrees. So I'm going to write that in the picture. And then you'll notice that in triangle BDC, which is the one that we're looking at, I now know two angles, 40 and 80, which means I can figure out the third. So in order to do that, you can always add 2 and to get 120, and then you can remove that 120 from our 180-degree triangle, which leaves us with 60 degrees right here. So that means for BDC, I have a triangle with an 80, 60, and 40-degree angle, which means that all three are acute, and therefore it's an acute triangle. Now, triangle ADC, our last one, that looks to be the entire outer triangle, so ADC. A is 40 degrees. Angle D, remember we're focusing on the entire angle, is 90 degrees, so I could actually just immediately stop because that 90-degree angle means that it's going to be a right triangle. Moving on. Classify each angle by its sides. Well, let's think about our options first off when it comes to sides. We have equilateral. That's if all three angles, or excuse me, all three sides are the same. We have scalene, if all three sides are different. And we also have isosceles, if exactly two sides are the same. So I take a look at the first one on problem 2, and I see that 1, 2, 3 sides are all the same. And so that instantly tells me that it's going to be equilateral. Next one, I see that all three sides are different. There are no two sides that are exactly the same, so therefore that's going to be a scalene. And finally, this third example, we have two sides that are the same, which means that it's going to be an isosceles. And I'm now just realizing that that's the same order that we wrote them up above, and I totally didn't know that, just a little coincidence. So that's fun. Moving down to number 3. Now we're incorporating a little bit more. We have to do some solving. So solve for x, and then find each side length and classify the triangle by its side lengths. So multiple steps to this. Taking a look at this first example, I'm noticing that it's an equilateral triangle based on three sides being the same. And since these expressions are for each of the sides, I can actually just immediately set those equal. So I have the equation of 5x minus 1 being equal to 4x plus 1. And now I can solve. We're going to go through the solving motions. Let's see. How about we subtract 4x from both sides? That leaves me with x minus 1 equal to positive 1. And now I'm going to add 1 to both to cancel. And I'm left with an x value that equals 2. Now that's not our final answer because it does say to find each side length. So I'm going to substitute that in here. 4 2's plus 1 equals 9. We'll substitute it in here just to double check our work. 5 2's minus 1 also equals 9. And then this side is equilateral, or I should say that it is an equilateral triangle, so this side must be 9 as well. All right. Next one. What can we do? I suppose that our clue is right here. And by clue, I mean that we know based on that single dash and single dash that these two sides have to be the same. So that actually means we can immediately solve it and state that x is equal to 15. Check. Now we're supposed to plug things back in. So that means that this side is a length of 15. And this side is a length of 15 plus 6, which means it's 21. And that means that this triangle is also isosceles. And I suppose that I forgot to write down my classification for the first one, but we did state it verbally. This one was equilateral. All right, moving down to 4. Supposed to find the measure. Okay, remember that the measure means we're supposed to figure out the number of degrees for each angle. This problem is asking for angle VWY. So let me snag a highlighter here real quick. VWY, where are you? VWY, that is here, here, here. Okay, so what I'm noticing about this angle, my first thought is that it's an exterior angle. And we've discussed how an exterior angle on a triangle is equal to the sum or the addition of the two remote interior angles. So I can actually say immediately that the measure of angle VWY is equal to 40 plus 80, which are the two remote interior angles, which means that that one is 120 degrees. Just to give you another option, we could have discussed how 40 and 80 together, 40 plus 80, make 120. You could always subtract 120 from the full triangle of 180 to realize that this third interior angle is 60. And then you could tell yourself that these two are a linear pair, which means that this one would have to be 120, which supports our first answer, which used the exterior angle property. All right, moving on. Let's go over to the measure of angle L. Angle L is right here, and I can think of a couple ways to approach it. This exterior angle gives me a lot of information. If I like, I could simply use the fact that together these are a linear pair, and therefore this angle, angle LJK on the interior of the triangle, would be 180 minus 130, which equals 50. That's not the one that we wanted, but that's just one more on the inside, which helps me get closer to finding the measure of angle L. Now that I know 2 on the inside, I can do our old trick of add 2 and then remove them from 180. So 50 plus 65 is 115. And I'm now going to remove from my triangle of 180 the two angles that I know about, which is 115, which leaves me with a nice 65-degree angle for angle L. All right, almost halfway home. Dropping down to number 5. Use the figure below to solve for x. Okay, my first thought is I look around for clues when it comes to the side lengths. We are not told, or excuse me, this is about angles. So I'm looking at the 3 angles, and I notice that none of them are listed as the same. But since we have something for all 3 of the angles, we do know that all 3 angles make 180. That's a guarantee. So that means that I could make a really big equation of one of the angles, 7x minus 13, plus another angle, 4x plus 9, plus the third angle, 2x plus 2. And it's a guarantee that all 3 of those angles added up equal 180 degrees. So now I'm just sitting on a pretty big equation, but if I'm disciplined, I can just take it step by step. 7x plus 4 more x's plus 2 more x's is 7, 11, and 2 more makes 13. And then taking a peek at our other like terms, we have a minus 13 plus 9, which puts me at minus 4 plus 2 more. So minus 4 plus 2, that puts us at minus 2. And then we still have that all of that is equal to 180. 2 steps away, we're going to add 2 to both sides. And that leaves me with 13x equals 182. And then I could divide by 13 and by 13, scratch, scratch. And I don't have a calculator in front of me, but I will in one moment here. X is equal to, wait 1 second, 182 divided by 13. Boom! Oh, nice. So this comes out to a nice even 14. Okay. Front side's done. Moving pretty well. Let's go ahead and flip over. All right, number 6. Find the measure of the indicated angle. So based on this figure, and notice there are 3 triangles in here. You have the triangle, the smaller one on the right, the smaller one on the left, and the entire triangle itself. You want to be using your different clues. For instance, that exterior angles equal the 2 remote interiors, that all 3 in a triangle make 180. You may want to focus on having a linear pair. I'll tell you what, before even dealing with the individual questions, I'm just going to fill in what I know. I'm looking in this triangle on the right, and for this angle, angle B, I know that I have 2 in this smaller triangle already. So I'm going to take those 2, 49 plus 84, which makes 133. And then I could remove that 133 from a full triangle of 180, which means that angle B is a 47-degree angle. So I'm just filling things in to try to make my life a little bit easier later on. I could focus in right here pretty quick and tell myself that these are a supplementary pair, which means that this one would be 180 minus the 84 next to it, which leaves me with, what would that be? 96 degrees. Okay. Now I could tackle this one. This angle, when I'm looking on the smaller triangle on the left, I already know that there is 46 and 96. So 46 and 96 makes 142. And I could now remove 142 from the full triangle, which leaves me with a 38-degree angle here. So now that I have values for each of the angles, I feel ready to tackle any question pretty quickly. So let's take a peek. The first one is the measure of angle DAC. DAC, well, look at that. We already took care of that. So that's going to be 38 degrees, and that's based on the work that is shown right here. The measure of angle ACD, A to C to D, that's the 96 degrees that we already did the work for. And then finally, the measure of angle ABC, A to B to C. That was actually the very first work that we did, which was 47 degrees. So we kind of tackled all those ahead of time. Number 7, find the measure of the indicated angle. Okay. Well, this is using the idea that in a right triangle, you know that 90 degrees have already been taken. And so what that guarantees us is that the 2 acute angles, they are complementary. They add to 90 as well. And so if you know one of the acute angles in a right triangle, you can instantly get the other one by simply doing 90 minus the one that you know. So that means that the measure of angle C is going to be 39.8 degrees. Same drill for the second one. You already have 90 degrees taken up right there, so that means that these 2 acute angles in a right triangle are a complementary pair, which means that for angle L, I could simply do 90 minus the 41-degree angle that's already provided, which shakes out to a nice even 49 degrees. All right, moving through. Now, numbers 8 through 10 deal with this concept of congruency, things being exactly the same. Now, remember, there are 5 different shortcuts: angle, angle, side, angle, side, angle, side, 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 angle, side, where that angle is included or sandwiched between the sides, and then finally hypotenuse leg. So let's take a look at what we have. Remember, feel free to always add in some information if you know for a fact that it's true. So I'm taking a look at this first one, and I know that I have vertical angles right there. What else do I know? Oh, I'm sorry. Let me read the directions a little bit more careful. What additional congruence would you need? So this is the type of question that is saying, hey, I will allow you to make one congruent statement so that we could then use angle, angle, side, or whichever one is provided. So now that I have incorporated the angles, we already had the sides, check. We now clarified the angles that were already there based on vertical, check. That means that we need to make a statement about one more angle pair that would go in the order of AAS. So that means I do not want to choose this angle and this angle. The reason is that would make ASA, and that's not what we're going for. So that means that we would have to make the congruent statement of angle D being congruent to angle T. Next one, angle side angle. So we already have the sides listed, scratch. We already know that these angles are congruent because of vertical angles, scratch. That means that we need to make a congruent statement about a pair of angles, but remember, now this needs to go in the order of angle side angle, where that side is included or sandwiched between the two angles provided. So that means that we are going to choose angle B and angle R this time. Angle B being congruent to angle R. Because after that selection, we do have the angle side angle in that order, congruent to angle side angle. On our first example, it would look like angle, an angle, and then a side. That side was not sandwiched between. Next one. We're being asked to use side, side, side. Well, we already have one pair of sides. Check. We can state that XZ is congruent to itself by the reflexive property. Check. That means that we need to make a statement about the third pair of sides. So just take a look and select the pair of sides that haven't been used yet. So that would be that side DX is congruent to side YZ. Next one. We're supposed to use side angle side. Once again, we already have a pair of sides listed, scratch. We know that XZ is congruent to itself by the reflexive property, scratch. So that means that we're supposed to make a statement about a pair of angles that is specifically sandwiched between the two sides that we've already clarified. So let's take a look at the picture. That means that we would need this specific angle being congruent to this specific angle, because then we would be left with a side, and then as we move along the picture, an angle, and then the other side that makes this angle included between it. So naming those angles, we do need to be specific, because from point Z, there are multiple angles that come from it. So we're going to have to use three letters, which would be angle DZX being congruent to angle YXZ. Next one, and last one for this type, hypotenuse leg. So remember, this deals specifically with right triangles, which we can see that we're working with. The piece right here that is provided that's already congruent, that's one of the legs. Remember, the hypotenuse is always opposite the right angle. So that means that we need to make this statement about the hypotenuse. So that means that we would want to state that side LN is congruent to side PR. Whew! Okay, we're almost home. Nice job staying with me. Remember, at any point you can always pause this and rewind and take your time to make sure that I'm not speaking too fast for you. Number 9. Here's a lovely piece of information. So remember, that's referred to as a congruence statement. If you have that congruence statement, you can instantly make a lot of conclusions because you know that the order matters. For instance, I know that angle A, which is the first letter, is going to be congruent to the first letter in the other triangle, so angle X. So I'm going to go along and frankly just follow the letters. So once again, angle A, first letter, will be congruent to angle X, the first letter. Dropping down, I know that angle B, second letter, will be congruent to angle Y, second letter. And finally, angle C, third letter, will be congruent to angle Z, third letter. Sliding over to sides, which use two letters for the naming, side AB would be first and second letter, so that'll be congruent to side XY, first and second letter. Side CB, throwing a little curveball in here. CB would be the third and second letter, so that will be congruent to side ZY. You can't fool me. And then finally AC, first and third letter, would be congruent to side XZ, first and third letter. All right, last one, number 10. Name the postulate that you would use to prove the two triangles are in fact congruent. Remember, the postulates are all the different shortcuts, to which we now have 5 of them in our tool belt. Just to list them to make sure that we're ready, Those are side, 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 angle, side, angle, angle, side, angle, side, angle, and finally hypotenuse leg, which deals specifically with right triangles. So let's take a look at what we have. Remember, on these pictures you can always include or recognize information if you know that for a fact that it's true. So when I'm looking at this first picture, I already see a pair of sides, I see an angle, and I'm willing to identify side WY as congruent to itself, and that's through the reflexive property. Now when I take a look at my markings, I see in side, angle, side, in that order, congruent to side, angle, side. The angle is sandwiched between the two sides. So this would be SAS. Next one. We already have two sides being congruent to two sides, and I have no problem saying that CA is congruent to itself, once again, through that reflexive property that we just discussed. So that means right out of the gates, we're dealing with SSS, and we actually don't need to be concerned with those angles. Next one. Whenever I have two segments or lines that cross each other, I know that vertical angles could be in play. Those are those angles that are opposite that crossing point. Let me note that really quick. Vertical, that's a vertical pair. And now that I look at it, I actually have angle, side angle, congruent to an angle, side angle. So it's sandwiched in that order. So this one would be ASA. Last two. I do note the right angles that are listed, and that means that these sides specifically would be a leg, and side WY, by the reflexive property, that's actually the hypotenuse of each of those smaller triangles. So after that we could stop and say that these are congruent by HL. Last one. What do we have? We really don't have a lot that's given to us. We only have one angle currently, but I could say that CA is congruent to itself, once again by the reflexive property. But right now you're dealing with only one angle and one side. This is where you need to be comfortable noting that you're dealing with some parallel sides, and you have parallel sides that have been cut by a transversal. Alternate interior angles are congruent. And now that we look at it, we have one angle, and as we continue around, a second angle, and then a side. AAS, congruent to one angle, continuing around another angle, and then the side. AAS. Whew! Alright, we did it. Smiley face. Alright, gang. I hope that worked out well for you and that your answers checked out. I hope to be back with you on Wednesday and or Thursday, but if not, just stay tuned for potential videos or lesson plans with whoever may be with you. Okay? I hope